Today we are going to discuss bouncing ball, which is coming under collisions topic. Okay, so this is a case where the collision is head-on collision, head-on, and it is inelastic collision. Okay, so actually the problem they will give you, like, this is a rigid surface they will give. So this surface, rigid surface, and which cannot be moved from one point to other point. Okay, from certain height, a ball, a rigid ball, again this is a ball which is rigid, and at a certain height, say h naught meters, it will be just dropped. Okay, so dropped means initial velocity 0. So whenever it is dropped here, due to gravity working down, it will come down. As it is coming downward, it will increase the speed. Okay, according to the formula that v square minus u square equals to 2as, it will increase where a equals to g, and just before it hits the ground, okay, just before it hits the ground here, it will have downward the speed. We will call it as u1. According to this equation, the speed is going to be root 2g h naught. Okay, and because of the impact with the surface, it will regain some velocity in the upward direction. So after impact, it will move upward with some velocity v1 that we need to find here. Okay, so with the help of this v1, it can go up to certain height, say h1 meters. Sometimes they will ask you to find h1 meters, how much h1 value. Okay, and otherwise it will come back again and it will hit the ground with the same speed v1, and again after second impact it will bounce back again, it may reach h2. Okay, like that it will continue some number of times, it will bounce, and again finally it will come to rest if it is inelastic collision. If it is elastic collision, it will never come to rest, it will keep on oscillating with the same height h naught. Okay, here our intention is to find out after nth bouncing, after n times bouncing from here, how much height it will go, or after how long, after how much time it will come to rest. Within that journey, how much displacement, distance, time taken, and also average velocity, average speed. All these questions we can answer here, and this can be asked in the JEE and also like JEE means level and also NEET level questions. Okay, so without late, we will consider the situation here. And here we want to find that v1, of course, first, and u1 we know. If you talk about the directions, I am taking downward direction as negative and upward direction as positive, because whenever you are dealing with velocities, you have to take care of the directions, because downward directions we should consider negative and upward direction we should consider positive. There is no restriction that always downward negative and upward positive. You can consider any direction as positive and negative, that depends on your comfort. Okay, so let us see what will be this v1 value. And here if you consider the collision topic, here first object is going to be ball, and second object is going to be surface. Okay, this is a surface. See, surface is not moving because of the impact of the ball. So before collision surface velocity, after collision surface velocity, both are 0, right? Then making use, we can say, from the coefficient of restitution. This formula, actually the derivation for this I am not giving in this class. Okay, I am considering direct formula for this. So that is what coefficient of restitution. General formula, it is velocity of separation divided by velocity of approach, or velocity of separation after collision divided by velocity of approach before collision. Okay, so that will be v1 minus v2 modulus, you can take, divided by u1 minus u2. Okay, you can consider modulus also, there is no issue in that. Here v2 and u2 are 0, obviously. v1 and u1 are not equals to 0, because u1 is under root of 2g h naught, it is just before it hits the ground, the velocity. V1 that we need to find. So if you substitute the values here, you will get V1 by U1, and we can say that V1 equals to E power 1 into U1. Okay, that is after first impact the velocity of ball will be E times U1, and if you talk about the direction of this V1, it is upward, whereas the direction of U1 is actually downward, so it is upward it will be. Okay, so with this V1, how much height it can go, that we can find from the formula. The height attained in the kinematics, h equals to what, u squared by 2g we can say. So h1, that is height after the first impact, equals to speed square by 2g. So we substitute that speed v1 square is this. I can take that h1 equals to e power 2 into if you substitute this u1 as this one, it will come h0. Okay, this is h1 after first impact. Similarly, obviously from here it will come back. When it is coming back, according to this equation, it will gain the speed again. Before it comes to before it hits the ground, it will again have the same speed but in the downward direction. Okay, so because of the conservation of energy again, okay, when it is going upward, it was starting from v1 velocity. Okay, as going upward at maximum height, its velocity becomes 0. When it is coming back, it will attain the velocity according to this equation, and when it is just before it hits the ground, it will have same velocity but in the downward direction. Okay, so for the second impact, v1 will be downward. After the second impact, that v2 will be upward. Okay, now again the same coefficient of restitution we can use, that E equals to general formula v1 minus, this v2 stands for, here v2 stands for surface velocity, here v2 stands for after the ball's velocity after second impact. Okay, don't you get confused, here v2 stands for surface velocity. Okay, and here v2 I am taking as velocity of ball after impact. Okay, so this if you substitute, it is going to be, anyway this is going to be v2, it will come minus 0 divided by v1 minus 0. Okay, what are these two zeros? These zeros are actually the velocity of surface after and before collision. Okay, that is what these zeros. Okay, and if you take this again, v2 equals to e times v1, and with this v2 it can go up to height h2, right, that h2 equals to v2 square by 2g. Then if you substitute there, trust me, you will get v1 is this, again if you substitute there, you will get e power 4 into h0, or in general you can generalize this, that h after nth collision equals to e power 2n into h0. This is the formula that you can have. And let me correct here something. Here let v2, like velocity of the surface after and before collision, let us take u2 prime and v2 prime, they are zeros, so that you can have here v2 prime, u2 prime. Okay, in some of your books you may not take this modulus. Okay, it doesn't make any difference. If you take your modulus, means there will be actually negative sign you will be getting. That negative sign indicates the direction only. Okay, and this is not the scalar subtraction or addition, it is a vector subtraction. You have to follow the parallelogram law. Okay, so I hope you got this, that after nth collision or nth impact, the height attained equals to e power 2n into h0, or it is h0 here, height of the ball from which it is dropped. Okay, with this we can go for the further. Okay.